project, named after the Roman goddess of gardens and orchards, is a project exploring a new synthetic construct combining plants, robotics, and artificial intelligence. Pomona stands for Plant Optimization by Mechatronic Neural Augmentation and describes the way in which the Pomona project seeks to enhance plants by the addition of robotic armatures and neural circuitry. In recent years, much attention has been focused on the search for new forms of energy to achieve both energy self-sufficiency and a reduction in the amount of greenhouse gas emissions. Solar, wind, and fossil fuels all ultimately derive their energy from the sun. Photovoltaic solar cells attempt this conversion as directly as possible. However, they still remain very inefficient and are expensive to manufacture. Consequently, many people have turned to using photosynthesis as a way of harnessing energy from the sun. Nature has provided us with a safe, natural way of converting solar energy into chemical energy in the form of biomass. In terms of greenhouse gases, biomass fuels have the advantage that they only put into the atmosphere the same amount of carbon dioxide that was originally taken out by the plant's growth and can be considered carbon neutral. Much new technology is being developed to take all kinds of plant materials and turn them into useful fuel sources, particularly bioethanol and biodiesel that can be used to power vehicles and avoid the use of CO2 generating fossil fuels. In the future, biotechnology promises sophisticated, efficient methods of converting waste vegetable material, like wood and chaff, into these useful fuels in second and third generation biofuel technology. However, in the rush to generate profit from green-sounding technologies, there has been a stampede to grow crops that can be turned into biofuels with existing technology. This first-generation technology uses fermentation to convert corn into ethanol and distillation to purify the result into a fuel with high energy density. Since this uses only part of the crop and is based on a plant that has been bred for food, not fuel, the efficiency of this process is rather limited. When taking into account all the energy that needs to be expended in harvesting the corn and converting it into ethanol, this efficiency is substantially reduced. Considerable opposition has faced the bioethanol movement that seeks to convert land from food production into the cultivation of crops for biofuels. Critics claim that this has led to rising food costs. Deepak Grugani of the campaign group Biofuel Watch describes the situation in Mexico, where there were recent protests over the rising price of corn tortillas.
Enormous amounts of what was formerly food are being drawn out of the food market and put into the fuel market, and therefore the prices are escalating. So if you imagine that food prices increase by 20, 30%, even 50% in some cases, and you're starting to get out of the reach of the common family, able to actually support themselves.
A further problem is the fact that land pressure caused by the increased demand may now cause the sacrifice of wilderness areas and natural habitats. Helena Paul of EcoNexus describes the threat in India.
Large amounts of forest are going to be cleared in parts of India, and that many indigenous and tribal peoples are going to be driven off their lands for that.
Pomona is an artificial life project that seeks to increase the yields of second-generation biofuels by helping plants to grow. Evolution allows only small incremental changes in plant design and has resulted in plants that are well suited to particular niches. But biotechnology is seeking to develop plants that better serve man's needs, by design rather than incremental optimization. In the Pomona project, we realize that plants lack fundamental capabilities that would enable higher yields, namely intelligence and self-awareness. Pomona concentrates on maximizing photosynthesis by adding robotic motion and artificial intelligence to ordinary plants. A plant species will develop with a particular shape and arrangement of leaves that is an evolutionary solution to a combination of factors, only one of which is photosynthetic yield. One notable plant ability is that of heliotropism, or being able to face towards the sun. Many plant families exhibit this trait, which orients the leaves so that the greatest surface area catches the sun. While plants are crudely able to reorient leaves towards the sun, as shown in this time-lapse video, their movements are slow and they lack a complex sensing mechanism that enables them to achieve the maximum photosynthesis. In the Pomona project, we provide plants with the motor and neural mechanisms to achieve mechatronic heliotropism. Governed by light sensors and diurnal awareness, the sun's angle is determined and the robotic mechanism steers the leaves of the plant to face the sun, as shown on a single leaf in this plant. Plants without heliotropism are thus able to track the sun and increase photosynthesis. In this case, we see a plant that evolved without heliotropism in low latitudes where photosynthesis is maximized with overhead sun. The Pomona controller steers the plants in both altitude and azimuth to maintain the sun directly above, again optimizing the photosynthesis in a way that the plant is unable to do by itself. One inefficiency of photosynthesis is that plants are self-shading. Higher leaves cast shadows on lower leaves, preventing them from photosynthesizing fully. Here we see a plant with a robotic prosthesis that is able to rapidly adjust the position of stems, moving them into patches of unused sunlight. The motors are automatically controlled by a computer vision program that observes the plant and its shadow through a camera. The internal processing of the vision system is shown here, with a segmentation of the image into leaf, background, and shadow pixels. Pomona constantly estimates the area of the shadow, and the robot moves the stem to maximize the shaded area, thus ensuring that the maximum amount of sunlight is being used for photosynthesis. In doing so, the combined Pomona-enhanced plant is able to respond more rapidly than a purely biological plant, to optimize over a wider variety of lighting conditions, and using a greater range of movement. This video shows a Pomona-enhanced plant augmented with robotic control for both heliotropism and avoiding self-shading. The Pomona controller can both move leaves into the sunlight and orient them to be perpendicular to the rays. Further, more sophisticated modeling is planned to allow the optimization to plan the plant's growth. With bioengineering, the plant's natural heliotropism and even its ability to self-support can be bred out and rendered unnecessary by the exoskeleton, and thus avoiding the need to divert growth resources into these redundant mechanisms. While the exoskeleton itself may be relatively costly to manufacture, it is designed to be reusable and applied to plants year after year. We look forward to a bright future with genetically enhanced plants, augmented with Pomona systems, generating abundant food and fuel for the entire planet.
Why now? 'Cause it's all about the price of oil. It's all about the price of oil. Don't give me no shit about blood, sweat, tears, and toil. It's all about the price.